Hello. Today I'm going to talk about the Big Bang lecture. And you've probably heard of the Big Bang. It's the event that started our universe. And we are fairly confident we understand how it progressed from the Big Bang to microseconds outside of the Big Bang to where we are now. We don't know what came before or how the Big Bang started. So we take a look here, and it has the expansion of the universe going from the Big Bang getting larger. Our universe started with an explosive expansion called the Big Bang. All of the matter in the universe was found in an infinitely small space. So all of space and matter was infinitely small, and then it would expand out from there. When Einstein was coming up with his theory of relativity, we didn't have a good idea of what space was looking like as far as was it getting bigger, was it getting smaller, was it staying the same? It was assumed that it was kind of constant. So Einstein used a math trick to keep galaxies at a fixed distance from one another. This is involving his calculations. This was assuming that the universe was staying the same. And then this image here is of an astronomer named Edwin Hubble. Later, Edwin Hubble would collect evidence that the universe is expanding. So now we know that the universe, the space, even the empty space, is actually getting bigger and bigger. This image here shows an example of how you can picture space expanding. So if you take a balloon, draw these points, and draw this wavy line, when you inflate the balloon and it expands, all the points get further away from each other. And this wavy line also gets bigger. That's what's happening with space. In an expanding universe, light gets stretched as space expands. So this is our light wave getting stretched out as space expands. Hubble used this to prove the universe is expanding. Now, in order to understand how old the universe is and how large the universe is, we have to gather more information. And what we've done is we have to have like objects that have a known brightness. So to get the velocity of galaxies, we need to compare redshift to something with a known and steady brightness. Type 1a supernovas always have the same brightness. So we use these supernova. Here's two pictures, right? Here's the galaxy, and then here's a supernova that happened in this galaxy. And it has to be a type 1a supernova. But those can tell us how fast galaxies are moving. And then once we know that, we can start to get an idea of how the universe is expanding, how quickly it's expanding. Now, for a long time, it was thought that the universe, if here's the Big Bang, that the universe would expand, but because of gravity, eventually would pull it all back together, and it would go from a Big Bang to a big crunch, is what they used to call it, where everything just smashes back together. You could have a couple other things here where it finds equilibrium, and it just stays the same size after a certain point. Or you could have universes that just expand evenly. But what it now looks like is this model here. So this is the one we're going to talk about. The fate of the universe depends on how the expansion proceeds. It was believed that gravity would pull the universe back together, but it now appears that the universe will expand forever. Now, both of these images show expansion of the universe, but one again has a very steady expansion and one has an accelerating expansion. It's getting bigger, faster, and faster. Expansion was slow in the early universe because gravity is stronger when matter is close together. So we had the Big Bang, and then early on, all of this stuff was close by. So gravity kind of kept it in check. It was still expanding, but it wasn't expanding as quickly. And then eventually what happens is the acceleration increases, and now it's getting bigger, faster and faster and faster. As galaxies got further away, expansion accelerated. So we're going to talk some more about this next week, but I hope that answers some questions. Thank you very much.